Group's learning outcome 6 is all about speed. And the first formula that we're going to look at is the one that you should be familiar with, either from first and second year maths or from physics as well. It's a distance, speed, time formula. Now, I'll usually write it this way around: d equals vt. You'll probably be familiar with it as v equals d over t. They both mean the same thing, but this one is easier to rearrange if you're trying to work out something that's on the right-hand side. Put a box around it when we introduce a new formula, and we define what all the symbols stand for. D is distance, so it's got to be in meters. So if it's in centimeters, you'd need to convert it. And our speed then will be written as meters per second. All right, now last year we wrote that as m/s, but this course we need to write it as ms to minus 1. I know some of you came across it last year. The minus 1 is a pair bit, it indicates that the seconds are pair. And t is time. Now I know it could be kilometres per hour and hours, but it won't be in examples for waves. Right, so that wouldn't be relevant for here. And then we'll do a simple worked example. Okay, so calculate the distance travelled by a wave with speed 6 meters per second in 5 seconds. I'm keeping it nice and simple to start with. Problem solving method. What does the question tell me? What does it ask me, and how do I link these together? So in the question it tells me the speed, and we use this v. Now later on in this course we'll explain the difference between velocity and speed, but we use v as a symbol for both of them. Okay, that's just the kind of internationally agreed symbol. The question also tells us that the time is 5 seconds, and it asks us the distance. So the formula is d equals vt. Nice easy example to get started with. Substitute in that the v is 6, because I know that, and t is 5. Notice I don't put the question mark in for d, because then you can easily lose track of what it is you're actually working out. And then your final answer with the unit and underline. Easy enough. Going to do an example 2, and I'm going to actually base it on the measurement that I took over there. So calculate the speed of sound when sound takes, I need to go over here to get the measurement, 0.00288 seconds. To travel 1 meter. So in the question here I'm being told the time, and the distance, and I'm being asked the speed. Now with this formula you could go straight to writing v equals d over t if you're familiar with it, but what I'm trying to encourage you to do is to get the skills of rearranging formulas. So I'm just going to write it the way I've written it at the top of this. D equals vt. 1 is my distance. V is what I'm trying to work out. And my time is 0.00288. How would I rearrange this to get what v is? Well, V is on the right hand side to start with, so the first thing, and normally I would just work down the page, but obviously I'm running out of room here. I'm going to go over here a wee bit. Is I'm just going to swap round both sides. I'm not changing anything. If 1 is equal to V times 0.00288, then V times 0.00288 is equal to 1. But it gets V on the left hand side. And then I'm going to get rid of the times 0.00288 by dividing that side by that value, because that will cancel out. But whatever I do to one side, okay, I have to do to the other. That last 8's just gone off the screen, but you get the idea. And then I get a calculator out, so they cancel out on that side. I get my calculator out and I do 1 divided by 0.00288. And that gives me, rounded off to 3 significant figures, 347 meters per second. So the wave equation is V equals F lambda. And once again, with any equation, we define what all the symbols stand for. V is speed, and what's its units? That's ms to the minus 1 meters per second. F is frequency, which is measured in hertz. And lambda is wavelength, which has got to be in meters. Just watch for that one. If they give you it in centimeters, you'd have to convert. If they gave you the frequency in kilohertz, you'd have to convert, stuff like that. Maybe we'll do a second example based on that sort of idea. So I'll generally start with a simple example and then look at one a bit more complicated. So calculate the speed of a wave with frequency 2 hertz and wavelength 5 meters. Easy one to practice your problem solving in. Go through the question. What does it tell me? It tells me frequency is 2 hertz, and it tells me that wavelength is 5 meters, and the question asks me the speed. So substitute into our equation then, select our equation which links these. And I suppose now we can kind of start to stress that this is where the problem solving method makes a big difference. You've now got multiple equations with V in them, multiple equations with F in them. So this is why it's important to list what the question tells you and what it asks you before deciding what equation you're using. Right? Because that will help you pick the correct equation, where you've got more than one equation it could possibly be. Once you've selected your equation, but it's just a case of substituting. So a nice easy one to get started. Example 2. So what could we do to make the questions a bit more challenging? I mentioned already we could maybe introduce some different units, so what we call prefixes to the unit. So rather than telling you what the frequency is in hertz, maybe we'll tell you in kilohertz. What else could we do to make the question more challenging? Okay, so if we're trying to calculate something on the right hand side, that can be a bit more complicated. So let's go with calculate the wavelength of a note with frequency 0.44 kilohertz. Now we've added another slight complication here. The question doesn't tell you the speed. It doesn't even tell you which kind of wave it is, but it kind of implies it. What kind of wave is this question dealing with? A sound wave, because it talks about a note. And what is the speed of sound? Well, we've just been working on that. Any suggestions for the speed of sound? Yeah. So the kind of what's called the textbook value of it is 340. We'll see that when you're doing it, you might not get exactly 340, but we'll discuss why that is. So in terms of my problem solving method, all I'm told here is the frequency. And when I'm listing that, I want to do any conversions that need to be done. So kilohertz means times 1000 hertz, times 10 to the power 3 if we were doing it that way. So if you do that calculation, you should find that that note is 440 hertz. And the question asks me the wavelength. So in terms of analysing the question, that's the only information we've got, and that's what we're being asked. What's missing though is, well, the only equations which link frequency and wavelength is this v equals f lambda one, so the v is missing. And in a test or in an exam, you'll get a data sheet at the start of the exam, giving you listing values of important things, like for instance the speed of sound in the air. So you can look that up and you get what we call the textbook value for the speed of sound is 340. Now we're ready to use our equation, v equals f lambda, substitute in what we can, and that gets you 2 out of 3 marks, remember, and the rest of the arithmetic we need to do to get the final answer, gets you the final mark. Some of you might be able to go straight from the line above to the final answer, but just in case, I'm going to put in all the steps that you could possibly need. Swap round both sides, so lambda's on the left-hand side now. And then simplify by cancelling out the 440 that's multiplying the lambda by dividing it by 440. Because quite often people say, how do I know what number to divide by? Well, the answer, what you're trying to achieve, remember, is to get lambda on its own on the left-hand side. So you're trying to get rid of the 440 times, so you divide by 440. And then you can get your calculator out and do your 340 divided by 440 on the right-hand side. Left-hand side simplifies to lambda, and the right-hand side, and you do your calculation, is 0.773 metres. Sorry, I've just run out of space there. But so echo problems are really just a special case. So quite often they're using sound or ultrasound. So ultrasound, so this is live data from yesterday, takes 9.465 ms. Any ideas what that stands for? Milliseconds, the same idea as millimetres, so we'll talk about that conversion in a wee second. To echo from the ceiling. How far away? Is the ceiling. So if I do my standard problem solving technique here, all I have is a time. And it's in milliseconds, whereas we really want it in standard units, which would be seconds. So milli is divided by 1,000. Or if you're happier, and you think you will find when we introduce more prefixes, I'm going to write that as times 10 to the minus 3. I'm going to use powers of 10. And I'm being asked how far away, so I'm being asked a distance. Now, from problem solving technique, that's what I'm being given, that's what I'm being asked. What's missing? If I'm going to link d and t together, there's a value missing, which is? Right, the speed is missing. So I go back to the question and say, does it tell me in the question what type of wave it is? Well, it does here. It tells me it's ultrasound, which travels at the same speed as sound. So the speed of sound in air is 340 meters per second. And in an exam, that will be contained in a data sheet at the beginning of the exam. You're not expected to memorize that. If it had been a radio wave for radar, then we'll revise later on that radio waves travel at the speed of light. So 3 times 10 to the power 8. Okay, but the time that we have is the time there and back. So the time we need, so I'll write that as t there, is the time there and back divided by 2. Okay, so I get my calculator out. So that is 4.7325 times 10 to the minus 3. Now we can solve the problem. The equation is d equals vt. D is what we're working out. Our v is 340, and the time that we use is 4.7325 times 10 to the minus 3. Put all that into a calculator, and it gives us 1.61 meters if we're rounding off to 3 significant figures.